Dear students, we'll continue today our chapter solid state. In the last class, we discussed the various unit cell like FCC, BCC, simple cubic, and the place of the atom, etc. Now, today with this presentation, today I'll show you one presentation, and with the help of this presentation, you will come to know what is the exact place of octahedral voids, tetrahedral voids, and the finally NaCl structure. Now I will share the screen with you. We can say this is the very simple unit cell, simple cubic या simple primitive बोल सकते हैं. This it has a 8 corners. You can say we can place 8 atoms on the corner because one cube contains 8 corners. And in the second slide you are watching, okay, this is the 6 atom placed center of the face. Each face center contain 1 atom. And you can see कि this is the place of atom center of the face, and the contribution is 1 by 2 because one face is shared by the another unit cell. This thing we discussed yesterday also. And the next slide, you can see that there is a 1 atom placed in center of the cube, and the contribution is 1 only because this 1 atom which is inside the cube cannot be shared by others atom. Now we come to the this slide. See carefully, there are the 12 edges and we place atoms on the center of the edges. So this type we can place 12 atoms because 12 edges in a cube. You can see I um, I place the red color atoms at the center of the edges, and similarly I place 1 atom in the center of the cube. This is the position of the octahedral voids. Up now the question is where the octahedral void situated. It is center of the edges and the center of the cube. Because the center of the edges are 12 places, so we place 12 atoms and 1 in the center. Now we talk about the contribution. You can say the center atom has contribution 1 because it is not shared with any other atom or another cube or another unit cell. But this edge, this one edge is shared by another 4 cube unit cell, or you can say cube. So the contribution of for every edge atom is 1 by 4. So what will we do? 12 atom, we place 12 atom on the cube. We'll multiply by 1 by 4. It comes to 3. Basically, we are placing 3 atoms as a whole at the edges and 1 atom as a whole in the center of the cube. So now the total number of atoms I am placing, that is 3 edges per, and 1 is on cube, that is 4. It means in FCC lattice we have 4 octahedral void. But if you want to ask the positions, the position is 13. 12 on the edges and 1 on the center. Similarly, now I will show you the position of the tetrahedral voids. Tetrahedral voids, the position of the tetrahedral void is, you can see what I did in this cube. I cut the cube in small mini cubes, small 8 mini cubes. What I did, I cut one cube vertically, then again I cut in another 4 parts. You can see there are the 8 mini cubes, and the center of each mini cube is the position of the tetrahedral void. Now you can easily imagine what is the position of tetrahedral void. And because tetrahedral void is inside the cube, so again there is no sharing of this atom with another cube or another unit cell. So the contribution of each tetrahedral void is 1 only. So it means there is a 8 position, and the total number of tetrahedral void we can keep is 8 only. I think now you can understand the position of octahedral void and tetrahedral void. Now the main topic of our discussion is NaCl structure. We'll discuss. See, this is the NaCl structure. In NaCl structure, two atoms are there, sodium and chlorine. I showed you NaCl by green color and chlorine by red color. And you also notice the size of sodium atom is smaller than chlorine. And as you know, sodium is smaller than chlorine. Now the chlorine is the main atom. Main atom means it occupies the FCC lattice. FCC lattice means 8 atom of chlorine will place at a corner and 6 atom of chlorine at the face center. So you can see how I placing the atom. I placed 8 atoms at the corners, chlorine atom, red color atom, bigger atom, and 6 atom on the face center. I already shown you in the last slides. Again, I am revising. You can see this is the corner. I place 8 atom at the corner. Similarly, and I place 6 atom chlorine atom at the face center. Now you can see here the total 14 atom I place chlorine atom, 8 at the corner and 6 at the faces. And again, if I am talking about the contribution is corner. The contribution of corner is 1 by 8, 8 into 1 by 8 plus 6 atom on the centers, 6 into 1 by 2, that is 4. Now I'm talking about sodium atom. Sodium atom is a smaller atom. When we place 2 atom at the corner, there is a space between them. Now at this place we can put sodium atom. So this is the place of octahedral void. We already discussed the center of the edges is called octahedral voids. Now I place this small atom, sodium atom in the edges and one sodium atom in the center. You can see center. Similarly, so again sodium atom I wrote here, sodium atom in octahedral voids, so present at 12 edges and one in the center of the body. So total sodium atom is 12 into 1 by 4 plus 1, that is 4. So finally, how many atoms of chlorine we put? 4, and the sodium is 4. The formula will be Na4Cl4. So that is NaCl. So in this way, we design, or you can say we put the atom in NaCl structure. We should remember always one thing: the bigger atom is always occupy FCC lattice or lattice point, while the smaller atom occupy the voids, maybe octahedral void or tetrahedral void. I guess now you can understand the concept of octahedral void, tetrahedral void, and the NaCl structure. In the similar way, we can study the other structures also, like cesium chloride, KCl, ZNS,